Up until this point, we've had some explicitly stated equations that we were finding the derivative of, either with the product rule or the quotient rule. This time, all we have are pictures of graphs, and we want to do the same kind of thing because you can see that p of x is supposed to be the product of f of x times g of x, and then q of x is the quotient of those two things, f of x divided by g of x. And in no kind of way would you want to find what those two functions are. Like you're not actually going to point by point multiply these things together. No. Instead, we can just use both the product rule and the quotient rule for specifically at, say, 4 and at 7 to find the slope at just that point. Okay, we can handle this. Let's take a look. So what I would suggest doing first here on part A, where we want to find p prime of 4, that is equal to f of x, p of x is equal to f of x times g of x. I'm going to first write what the product rule would say about p of x, which its derivative should be f prime of x, the derivative of the first times the second, plus the first times the derivative of the second. Whoa, I almost put the derivative on that one. Okay, everywhere there's an x now, I'm going to go back with my eraser and put the number 4 because we're trying to find the derivative here at 4. Okay, now how I would do this then is everywhere there's just a function value, that's just going to be a y value from the graph, right? So both of these things are just y values. Anywhere there is a prime, so f prime of 4 and g prime of 4, in both of these cases, we're just going to get the slope of the graph there. Okay, so if it's a line, that part's going to be pretty easy. If it's this parabolic part that is right here, that might be a little bit more challenging, but I think that we can handle it. So let's see what the derivative of p at 4 is going to be. So the first thing that I need is f prime of 4. So the f is the bold black graph, and then at 4, well, notice it's just a line. And what is the slope of the line? The slope of the line here is exactly constant. It's the same exact value anywhere on this line. So if I go up 1 and over 2, looks like it's just a half. Apparently I switched to red, but okay, we'll just go with it. And now g of 4 is just a function value, so I'm just going to follow this thing straight up here. And look at that. It's right here at 8. We just want the function value there, so times 8, plus f of 4. Now we just want the function value on the black graph there, which is 1, times the derivative of the g of x function at 4. And look, we have ourselves a horizontal tangent line, so what's the slope right there? Slope right there should be 0, meaning that at 4, the slope is also 4. Okay, well, that's just the way that one worked out. Now, here's oh, I didn't close parentheses. Was that bugging you? It's bugging me after I noticed it. What if, for example, whenever we went to do this particular problem, what if it asked us to find the slope here or find the slope here? Well, notice that this is a sharp turn. That's a sharp turn, sharp turn, sharp turn. At each one of those sharp turns, the derivative would not exist, right? That's one of the places where a derivative fails to exist. Okay, but it's possible that I had to find this at 5 instead. How would I find the slope there? You're not going to estimate it. Instead, notice that this graph here, it just looks like y is equal to a negative x squared. Sure, it's been translated, and you can actually translate it if you want to, but just think of this point right here as the origin. So in other words, if I wanted the slope at this particular point, if I did, I would find this derivative of this kind of parent function right here, y prime is equal to negative 2x, and I wouldn't stick in the number 5, no. Remember, we're pretending like this is the origin. I would stick in the positive 1. So if I stick positive 1 in here, I get a slope of negative 2. right? And so that's what the slope is at that particular point. I'm just saying if I had to do it. Okay, let's look at Q. Q is the quotient. We want to find the derivative at 7. I'm going to switch back to blue here. So this was part A. So Q prime of 7, Q of x was equal to f of x divided by g of x. I'm fairly certain g was on the bottom. Okay, so once again, let's apply the quotient rule. My Q turned into a G. Did you notice that? Okay, so derivative of the top, f prime of x, times the bottom, g of x, minus, don't get the minus and the plus confused for the quotient rule versus the product rule, and then the top times the derivative of the bottom, all over the bottom squared. And then just like I did before, I'm going to go back with my eraser, take out all the x's, and put in a 7. And as we stated previously, all of these that are just function values that I'm going to get from the graphs, and then here we're going to get slopes to plug in. Okay, so maybe just to keep this consistent, I'll change over here to red. So the first one I want is the slope of the f graph at 7. So let me clean this thing up first because I wrote all over it. Delete. So where's 7? Oh, look, they just happened to cross right here. What does that mean? It doesn't mean anything. Okay, so we want the slope of the f graph at 7. So it's this whole entire black line. Should have the exact same slope. It looks like it goes up 2 and over 1. So the slope there is a 2 times my g of 7. That's just a y value. The g of 7 here looks like it's at 4. Minus f of 7 should be 4 also. How do I know that? Because remember, that's where they intersected each other. Also, right there at 4 times g prime of 7. What's the slope of the g function? And this one's going down, so it's negative, and it looks like it's just negative 1 down 1, right 1. Over, dang it. No worries, I can fix it. Over the denominator squared, which is g of 7 squared. We already found g of 7. It was this number, so it's 4. So I need 4 squared. And now just do some arithmetic to clean this up. If it was free response, this is technically safe stoppable. Like you could stop right here, but you know, in a multiple choice situation, we'd have to do the work. So we'd get 8 minus times a minus plus 4 over 16. 12 over 16, and let's see, we can reduce that by 4, which would give us a 3/4. So we just found the slope of our quotient function here at 7.